Good morning, friends. In chapter 11, we are going to discuss about the MCQ question asked in good set. Up to 2008 we discussed. Now today we start with the 2009. In 2009, the question asked in photoelectric effect, the threshold wavelength of sodium is 5000 angstrom is given. Find its work function. Here the threshold wavelength of the sodium is given, that is the 5000 angstrom. We have to find out what is the work function for the sodium. For that purpose, we know the equation of work function phi is equal to HF. So work function phi is equal to HF is equal to Hc upon E lambda we obtain in electron volt. Because we require the answer in electron volt. Therefore, Hc upon E lambda. Now we substitute the value H, Planck's constant 6.6, 10 is 2 minus 34. C, velocity of light 3 into 10 is to 8. Upon E, charge of an electron 1.6, 10 is to minus 19, and wavelength 5000 angstrom is given. Therefore, pi into 10 is to minus 7 meter. Pi into 10 is to minus 7 meter. So as we simplify this value, we obtain the answer is 2.475 electron volt. Approximate 2.5 electron volt. Again, in photoelectric effect, threshold wavelength of the sodium is given 5000 angstrom. We have to find out the work function for sodium metal. So here we know that the work function phi is equal to HF. That means the Hc upon E lambda, or we can also write the Hh0 is equal to Hc upon E lambda 0. Lambda 0 is the threshold wavelength, F0 is threshold frequency. As we substitute the value, we obtain the work function of a sodium is 2.5 electron volt. After that, the next, in 2010, question asked, photoelectric effect represents what? First is, the electron has a wave nature. Second, the light has a particle nature. C, A and B both. That means it also represents the electron has a wave nature and light has a particle nature. And last option is none of this. Now we know that the photoelectric effect cannot be explained by the wave nature of a particle. Again, the photoelectric effect cannot be explained by considering the wave nature of a light. Therefore, it represents the light has a particle nature. By considering the light as a particle nature, we can explain the photoelectric effect. So answer is that the photoelectric effect cannot explain by considering by wave nature of light. So it represents that the light has a particle nature. So that is depends on the theory. In the beginning we discussed about that, the reflection and reflection phenomena can be explained by the wave nature and also as a particle nature, while the interference and reflection phenomena can be explained the wave nature of light, while the Crompton effect and photoelectric effect can explain the particle nature of a light. Now the next, the frequency of the photon having the 100 electron volt energy is how much? We have to find out the frequency. We know that the energy E is equal to HF. We require the frequency, therefore F is equal to E upon H. Now E is given in electron volt, right? Therefore, we can substitute the value F is equal to E is equal to 100 into 1.6 into 10 raised to minus 19 divided by h 6.62 into 10 raised to minus 34. Again, the energy of photon is given the 100 electron volt. Find the frequency of this photon. So we know that the energy of the photon according to the properties of photon, E is equal to hf. Therefore, F is equal to E by h. Here h is in SI unit, joule into second, while the E is given in electron volt. Therefore, 100 eV, that means the 100 into 1.6 into 10 is to minus 19 upon Planck's constant 6.62 into 10 is to minus 34. Therefore, we obtain the answer is 2.417 into 10 is to 16 hertz. That is the frequency of the photon having the energy is equal to 100 electron volt. Now next, electron and proton move in same direction with equal kinetic energy. Ratio of their de Broglie wavelength will be. Again, the electron and proton both are moving with the same kinetic energy. Right? In same direction. What is the ratio of their de Broglie wavelength? So we know that the de Broglie wavelength lambda is equal to h upon p. Here the kinetic energy is given, the relation between the momentum and kinetic energy is P is equal to 2me, under root of 2me. Therefore, h upon under root of 2mk or the 2me. Here the x as constant, e as same, and 2 is constant. Therefore, lambda proportional to the 1 upon under root of m. 1 upon under root of m. Therefore, for electron, lambda e proportional to the 1 upon under root of me, and lambda p proportional to the 1 upon under root of m. Yes, we take the ratio of lambda e upon lambda p. So this ratio is under root of mp upon m. Again, the de Broglie wavelength lambda is equal to h upon p. Here the momentum is not given, but here the kinetic energy of the electron and proton are same. Therefore, de Broglie wavelength lambda is equal to h upon under root of 2me. Here the h constant, 2 constant, and E, kinetic energy of electron and proton are same. Therefore, lambda is only inversely proportional to the square root of m. Therefore, for electron, lambda E proportional to the 1 upon under root of me, and lambda P proportional to the 1 upon under root of mp. Now we are taking the ratio of lambda E upon lambda P. So we obtain under root of mp upon me. Now after that, work function of the surface is phi. When the photon of 3 phi energy is incident on surface, the electron with maximum speed of 6 into 10 is to 6 meter per second is emitted from the surface. That means the work function is given phi. Now the energy E is equal to 3m. At that time the maximum speed is V1. V1 is given, that is the 6 into 10 is to 6 meter per second. Now when the energy E2 is equal to 9 phi, at that time we have to find out what is the maximum speed of photoelectrons emitted. So we know that the Einstein's equation for photoelectric effect, there is the half m v1 square. Half m v1 square is equal to hf minus phi. And half m v2 square is equal to hf 2 minus phi. Phi are given same. Therefore, here we can say that there is the 3 phi minus phi. And here that is equal to 9 phi minus phi. So it's equal to 2 pi here, and here there is the 8 pi. Now we take the ratio of the kinetic energy half mv1 square to the half mv2 square. So we obtain 2 pi upon 8 pi is equal to 1 by 4. Therefore, v2 square is equal to 4v1 square. Therefore, v2 is equal to 2v1. Therefore, v2 is equal to 2 into v1. v1 is this 6 into 10 is to 6 meter per second. Therefore, 12 into 10 is to 6 meter per second is the velocity of the photoelectrons emitted from the surface. Again now, work function of the surface is given pi. Now, the photon of 3 pi energy incident on the surface. Electron with maximum speed of 6 into 10 is to 6 meter per second is emitted from the surface. If energy of the photon changes to 9 pi, what is the maximum speed of photoelectrons? So from Einstein's photoelectric equation, half mv2 square is equal to hf1 minus pi. And when the energy is E2 or the 9f, at that time the maximum kinetic energy is V2, therefore half mv2 square is equal to hf2 minus pi. hf1 is given to 3 pi. 3 pi minus pi, 2 pi. Here E2, hf2 is given to 9 pi. 9 pi minus pi is equal to 8. Therefore, half mv1 square is equal to 2 pi, half mv2 square is equal to 8 pi. Now we taking the ratio of kinetic energy in first case to the kinetic energy in second case, the 2 pi upon 8 pi, half m cancel, pi cancel, so 1 by 4 is remaining. Therefore, v2 square is equal to 4v1 square, therefore v2 is equal to 2v1. Therefore, v2 into 2. v1 is already given. 6 into 10 is to 6. Therefore, 12 into 10 is to 6 meter per second is the kinetic energy of the photoelectrons emitted from the surface. Now next, asked in 2012, if particle mentioned below moves with the same velocity. Velocity of the given particles are same, which will have the highest de Broglie wavelength. Now we know that the de Broglie wavelength lambda is equal to h upon b is equal to h upon m. H and v are constant because all the particle has the same velocity. Therefore, we can say that lambda proportional to the 1 upon m. Now, given 4 particles, neutron, proton, beta particle and alpha particle, which particle has the highest wavelength? So the particle having the highest wavelength, if their mass is less, we know that the mass of the proton 1.6 into 10 is to minus 27 kg. Neutron is the same, has also the mass, right? And alpha particle has the mass is to 4 times of the proton, while the beta particle is the electron. So electron has the least mass, therefore the beta particle, that means the electron, has less mass. So, de Broglie wavelength of beta particle is the highest. From this equation of de Broglie wavelength, lambda is equal to h upon p is equal to h upon mp. Here all the particle moves with the same speed with the same velocity. Therefore, lambda is inversely proportional to the mass. Out of these 4 given particles, the beta particle, that means the electron, has the least mass or the less mass. Therefore, its de Broglie wavelength is highest among the given particles.